If the sun vanished, would Earth feel it instantly or after 8 minutes? Your answer depends on whether you trust Newton or Einstein. Einstein says 8 minutes because gravity is a ripple in the fabric of space-time, not an invisible string pulling instantly. Every planet, every star, every black hole warps the fabric of space-time. And you are falling along these curves right now, not because a force pulls you, but because the geometry of the universe dictates your path. In the next few minutes, the 5 reasons space-time curves. From the stress-energy tensor to the geodesic equation. No metaphors, only general relativity. Before we begin this journey of exploration, please hit the subscribe button to help support us in bringing you even higher quality content in the future.
I've known since school, gravity is a force that pulls things together. The sun pulls the earth pulls the moon. Simple. But you're about to tell me that this force is an illusion, that what I feel as weight is actually geometry whispering to me through the shape of space and time.
Newton's gravity is a good approximation. It got us to the moon. But it's wrong. Einstein saw deeper. He realized that gravity is not a force at all. It's geometry.
Geometry? How can gravity be geometry? Geometry is shapes, triangles, circles, not falling apples, unless the space through which the apple falls is itself curved, and the apple is simply following the straightest possible path through that curvature.
5 causes, 5 reasons why Einstein was right. They explain why space-time is curved, why gravity is not a force, why the universe is a fabric, not a stage. And once you see gravity as geometry, you'll never feel your own weight the same way again. You're not being pulled down. You're being pushed into a curved path by the shape of the universe itself. Cause 1. The Equivalence Principle. Einstein had a brilliant thought experiment. If you're in an accelerating elevator, you feel a force pushing you to the floor. That feels exactly like gravity.
So acceleration and gravity are indistinguishable? You can't tell the difference? That's profound. It means the force you feel depends entirely on your frame of reference.
That's profound. It means
what you call gravity, I might call acceleration, and neither of us would be wrong.
Exactly. If you're in free fall, you feel weightless. That's because you're following the curvature of space-time. Gravity is not pulling you. You're just moving along the natural path. Einstein called this his happiest thought. It meant that if gravity and acceleration are the same, then gravity must be a property of space-time itself, not a force transmitted magically across empty space. No more action at a distance.
So the first cause is simple. Acceleration and gravity are the same thing. That's why Einstein could replace gravity with geometry. It's not just a clever analogy, it's an exact identity. The equivalence principle tells us that the gravitational field can be transformed away simply by choosing the right frame. You can't do that with a real force.
The equivalence principle was the key. It unlocked the door. Once Einstein realized that gravity and acceleration are identical, he knew gravity must be geometry. Cause 2. Mass energy tells spacetime how to curve. Einstein's field equations are the most beautiful equations in physics. They say energy and mass warp the fabric of the universe.
So mass creates curvature. The more massive an object, the more it bends spacetime. Then the question becomes, what exactly is doing the curving? Is it just mass, or is energy included? And is there an equation that tells spacetime exactly how much to bend?
The sun curves spacetime the most. The Earth curves it a little. The moon curves it a tiny bit. The moon orbits the Earth because it's following the curvature created by the Earth. And the equation that governs this is the Einstein tensor. G mu nu equals 8 pi times the gravitational constant G times the stress energy tensor T mu nu. The left side, the Einstein tensor, describes the geometry. The right side, the stress energy tensor, describes the distribution of mass, energy, momentum, and pressure. Everything with energy curves spacetime, even light.
So density matters too. A neutron star has the same mass as the sun, but is much smaller. The curvature is much more intense. That means the curvature depends not just on how much mass you have, but how tightly you pack it. Compress something enough, and its surface gravity becomes inescapable. That's how you make a black hole.
Asterisk, mass energy is the source of curvature. Without it, space-time would be flat, empty, featureless. This is the second cause. The cause of all gravity. Cause 3. Curved spacetime doesn't just bend space, it bends time too. Near a massive object, time flows slower. This is gravitational time dilation.
Time slows down, like in the movie Interstellar, near the black hole. But that's not science fiction, is it? That's an engineering problem we solve every day with GPS satellites. Without Einstein, our maps would drift by kilometers.
GPS satellites have to correct for this. Their clocks run faster because they're farther from Earth's gravity. Without Einstein's correction, GPS would be off by 10 kilometers every day. And it's a dual correction. Special relativity says moving clocks run slower, the satellites move at 14,000 kilometers per hour, while general relativity says clocks in weaker gravity run faster. The net effect is about plus 38 microseconds per day. Engineers have to account for both. Your phone navigates using Einstein's field equations.
So time is not absolute. It flows differently in different places. That's the third cause. Newton thought time was a cosmic clock ticking uniformly everywhere. Einstein showed that time is local. It stretches and compresses depending on where you are and how fast you're moving. There is no universal now.
Time is part of the fabric. It stretches and compresses. Gravity is not just the curvature of space, it's the curvature of space-time. Space and time together. Cause 4. Light bends. Einstein predicted that starlight passing near the sun would be deflected by its gravity. In 1919, Arthur Eddington measured this during a solar eclipse. Einstein became a superstar overnight.
Light has no mass. How can gravity bend it if gravity is curvature? If it has no mass, Newton would predict zero deflection. So if light bends, it's not gravity pulling on a particle, it's the space itself being curved. and light simply following the terrain?
Because light follows the curvature of spacetime. It doesn't matter that it has no mass. It's just following the straightest possible path in curved space. That path appears curved to us. Newtonian gravity actually predicted half the deflection. But Einstein's theory predicts twice as much, because time is curved too. Eddington's 1919 eclipse expedition measured the full Einstein value. That's when the world knew space-time is real, and it bends.
This is gravitational lensing. We see galaxies behind a cluster, stretched into arcs. The cluster's gravity bends the light. That's the fourth cause. It turns the universe itself into a telescope. Massive clusters become cosmic lenses, letting us see galaxies that would otherwise be beyond our reach. A free gift from curved spacetime.
Light bends because space is curved. This is direct evidence. The universe acts as a giant lens, and we use this lens to see galaxies that would otherwise be invisible. 'Cause 5. Gravitational waves. When massive objects accelerate, they create ripples in spacetime. Einstein predicted them in 1916. It took 100 years to detect them.
Gravitational waves? Like ripples in a pond? So when two black holes merge, they don't just sit there silently. They send actual physical distortions racing across the universe. And we built machines sensitive enough to catch them?
LIGO detected the first gravitational wave in 2015. Two black holes merged 1.3 billion light-years away. The ripple stretched and squeezed LIGO's 4K arms by 1/1000th the width of a proton. To put that in perspective, that's like measuring the distance from Earth to the nearest star, 4.2 light-years, and detecting a change smaller than the width of a human hair. That's the level of precision required. And we achieved it.
That's the sound of space-time ringing. The universe has a song, and we finally heard it. It's not just a detection, it's a new sense. We've given the universe a hearing test, and it passed. Every merger, every supernova, every asymmetric acceleration sends its own signature ripple across the fabric.
Gravitational waves are the fifth cause. They prove that space-time is a real physical entity. It can stretch, it can ripple, it can ring like a bell. So gravity is not a force pulling things. It's the geometry of the universe. Matter tells space how to curve. Curved space tells matter how to move. It's a dialogue, not a monologue. Mass speaks, space-time listens, and reshapes itself. And that new shape tells mass where to go next. A cosmic conversation written in geometry.
So gravity is not a force pulling things, it's the geometry of the universe. Matter tells space how to curve. Curved space tells matter how to move.
Black holes are the extreme case. They curve space-time so much that even light cannot escape. They are the tears in the fabric. At the singularity, the curvature becomes infinite. Our equations break down. General relativity predicts its own failure. It tells us that at the heart of every black hole, there's a place where we need a deeper theory, a quantum theory of gravity. The fabric doesn't just stretch there, it snaps.
The universe is not a collection of objects in space. Space itself is a participant. It bends, it flows, it lives. We've moved from a universe of billiard balls on a fixed table to a universe where the table is part of the game, where the stage itself dances with the actors.
This is Einstein's legacy. He showed us that the universe is not a void, it is a fabric, a dynamic, living fabric, and we are part of its curvature. 5 causes, 1 fabric. The cosmos is not a stage, it is the dancer, and we are finally learning to see the dance.
So Newton was not wrong. He was incomplete. His gravity works for apples and planets. But for the universe, we need Einstein's fabric. That's how science progresses, not by proving previous theories wrong, but by revealing them as special cases of something deeper. Newton's gravity is Einstein's gravity in the limit of weak fields and slow speeds.
And that's the beauty of science. Each generation sees deeper. Newton saw forces. Einstein saw geometry. The next generation will see something else. We already know that general relativity and quantum mechanics are incompatible. Somewhere, there's a deeper theory, quantum gravity, that will make Einstein's field equations a special case, just as Einstein made Newton's inverse square law a special case. The fabric may be even stranger than Einstein imagined.
Space-time is a fabric. It curves, it ripples, it stretches time itself. We are not separate from it. We are embedded in it. Part of the dance. We don't live in the universe like passengers in a vehicle. We are ripples in the fabric itself. Temporary, complex patterns in the geometry, briefly aware of the shape that gave us form.
And the fabric is not static. It expands. It accelerates. Dark energy is pulling it apart. Black holes are tearing it. Gravity is weaving it together.
The universe is a living thing, a fabric of space and time, and we are part of its warp and weft, threads in the cosmic tapestry.
That's the lesson, Minto. You are not standing on a stage. You are part of the fabric. Every atom in your body curves space-time. Every heartbeat sends ripples across the cosmos. You are not a passive observer of the universe. You are an active participant in its geometry. Your very existence warps the shape of reality, however slightly. And that's not poetry. That's physics. 5 causes. The Equivalence Principle. Mass energy. Time dilation. Bending light. Gravitational waves. They are the reasons why the universe is a fabric. Why gravity is geometry.
Thank you, Kaler, for showing me that the universe is not empty. It's a fabric, and I'm part of it. Not just standing on it like a character on a painted backdrop, but woven into the very threads of space and time, my mass bending it, my clock ticking to its curves.
That's what I do, my boy. I help you see the fabric. Einstein saw it, now you see it too. And once you see it, you can't unsee it. Every time you feel your own weight, you'll remember, that's not a force pulling you down. That's the earth reshaping the geometry around you, and you following the curve.
The fabric of the cosmos, not empty, not static, alive. And we are the part of it that knows it exists. We are the geometry that became conscious, the curve that learned to calculate its own curvature.
Space-time is the stage, but it's also the play, It's the actor, the director, the audience, and we are all woven into it. The universe is a living tapestry,